Consuelo Mathletes. Today, we're not going to talk about graphs in general. We're going to talk about a very specific type of graph, and that is a line. So prior to today, I talked about graphs in general, functions, et cetera, et cetera. Today, I'm going to restrict myself to lines. Now, so first of all, you need to know what makes something a line. And I don't mean how do you draw a line yet. What I mean is when you look at an equation, how do you tell if it's a linear equation or not? Now, I've already mentioned this, and I'll mention it again later. But the main thing, if ever you want to know what type of equation you've got, what you do is you look at the variable. And in the case of a linear equation, the main thing you're looking for is x to the first power. Okay, the variable, actually all variables, not just x, but the variable to the first power. Okay, so for instance, and I don't think you necessarily need to write this down, but just listen. By the way, for this file, you need to have your own paper. There's no downloadable notes. Anyway, so what about this? That's the equation of a line. Why? Because the variables are all to the first power. And also I want to point out there's no other mathematical operations around them. Okay? Now, so what if you have this? All right? That's not a linear equation. Okay, you may think the variable's to the first power, but actually it's not. I'm not going to go into it. We'll do that later on in the year. But that's not a linear equation. That's a radical equation. And I'll get into why the variable's not really to the first power, even though it may look like it. I'll get into that some other time. Okay? How about this? That is not a linear equation. Why? It may look like the variable's to the first power, but it's got absolute values around the variable. Okay? This would not be a linear equation, right? Because there's an absolute value around the variable. This would be an absolute value. This would be a linear equation, though. Why? Because the absolute value is not around the variable. That would graph as a line. Okay? So what we're looking at are linear equations. Now, what if you have this? Okay, that's a linear equation. All right, there's no, notice the division is the division of the whole quantity. This would really just be the same thing as 3/2 x plus 7/2. So that would be a linear equation. What if you have this? That would be a linear equation. Why? Because the parentheses, yeah, they do indicate multiplication here, but basically this is just the same thing as 3x plus 21. Not that you necessarily need to write that, but that would still be a linear equation. So when I'm talking about a mathematical operation around the variable, parentheses are not a mathematical operation. Okay? Now, yeah, they indicate multiplication, that's true, but there can be addition, there can be subtraction, there can be multiplication, there can be division, but not anything like an absolute value or a radical or anything like that. So, and someday I'll tell you the full-blown definition of what a linear equation really is, but at this point I think it would make things even worse. So anyway, so I want to make sure you know what it is we're talking about. Okay, so we're talking about a linear equation. Now, that's a linear equation. That's a linear equation. That's a linear equation. And we'll get to these different types of linear equations eventually. But what I want to start off with is something that, quite frankly, applies to anything. It doesn't just apply to linear equations, but we're only going to apply it to linear equations because that's what we're dealing with right now. So up until this point, I've told you if you don't know what to do, you make an XY table to graph something. So prior to today, if you just made an XY table to graph any of these three that are, and you don't need to have these three written down, I'm just saying these are linear equations. Anytime you don't know how to graph something, you don't know a shortcut, you make an XY table. That's all I would expect for these right now. Oh, except for about 2 minutes, I won't accept an XY table for lines anymore because I'm going to teach you a shortcut. And the shortcut I'm going to teach you will work for anything, but we're only going to apply it to lines. And that is the x-intercept and the y-intercept. Now, the x-intercept is where a graph crosses the x-axis. Pretty simple. And the y-intercept is where a graph crosses the y-axis. All right. So what do I mean by that? Now I'm going to draw something underneath this and then, well, I'm going to draw it off to the side here. Again, I just want to point out you don't really need these three equations written down. It's fine with me if you do, it's fine with me if you don't, but it's not necessary. Okay, so I'm going to draw something on the top here. Just a graph. Okay, there's the x-axis. There's the y-axis. And I'm going to draw something that's not even a line. Okay, there's a graph. All right? What do I mean by the x-axis? It's where the graph crosses the x-axis, or the x-intercept, where the graph crosses the x-axis. There are three x-intercepts here. There's one right there, there's one right there, and there's one right there. Okay? Y-intercept, where graph crosses the y-axis. There's one y-intercept here, and it's right there. Okay, so that's all I mean by and again, you don't need to write that down. I just want to make sure you understand what I mean. Now, there's something I want to point out, though, about any point on the x-axis. Okay? Okay, so let's just take a look at the x-axis for a second. Okay, what is that point? And if I kind of label the axes real, and you don't need to, just listen, that's good enough. Okay, what's that point right there? That's 1, 0. What's that point right there? That's 2, 0. What's that point right there? That's 3, 0. So on and so forth. What's that point right there? That's 0, 0. What's that point right there? Negative 1, 0. What's that point right there? Negative 2, 0. And hopefully you get the idea here. And what can you say is true about every single one of those points? What can you say about every point on the x-axis? It's got a y-coordinate of 0. That's true for every point on the y-axis. Sorry, for every point on the x-axis. So what do you do to find the x-intercept? Remember, every point on the x-axis has a y-coordinate of 0. Every x-intercept has a y-coordinate of 0. So what do? You substitute 0 for y in the equation. And again, you don't need all these little sketches I've drawn. And again, I'll erase them, but you do need to have that written down. And now let's maybe take a look at the other axis, and hopefully this is obvious to you. What's this point? This point is 0, 0. What's this point? It's 0, 1. What's this point? It's 0, 2. What's this point? It's 0, -1. And this point is 0, -2, et cetera, et cetera. And what can you tell me about all of those? Well, I hope it's obvious. Every single point on the y-axis has an x-coordinate of 0. So what do you do to find a y-intercept? You substitute zero for the x variable in the equation. Okay? All right, I'm going to get rid of this picture because, again, this wasn't even a line or anything. I just kind of wanted to give you an idea. Okay. So, if something's a line, what's one way? I'm not saying it's the best way, but what's one way that you can use to graph it? Find the x and the y-intercept. Because remember, a line, you only need 2 points to draw a line. And the x-intercept will give you 1 point, and the y-intercept will give you another point. So let's say I ask you to do this. Let's say I ask you to graph 2x minus 5y equals 8. Okay, now that's a line. That's the equation of a line. How do I know it's a linear equation? Because the variables are to the first power and there's no other mathematical symbol around the variables. So right now, how can you graph this? All right, and what you can do is find the x-intercept and you can find the y-intercept. And real quickly, how do you do that? Now, I'm just going to do it the way you should be doing it. Okay, find the x-intercept. In your head, stick a 0 in for the y. And what does negative 5y become? 0. So you have 2x equals 8 and x equals 4. So it's 4, 0. I'll come back and do that again for you. How about the y-intercept? Stick 0 in for x. That becomes 0. And you get negative 5y equals 8. So you get 0, negative 8/5. And now all you got to do, and again, I'll come back and go through that. Gosh, that's a nice line there. Okay. All you got to do is plot the point (4, 0), which is right there. 0, negative 8/5. Just eyeball it as best you can. Okay, so we have, that will be negative 1 3/5, which is right about there. And then draw your line. And just draw it as best you can. Okay. Now, what have we done here? We've shown every XY pair that can be substituted for X and Y into the equation that will make the statement true. If I take any one of these points on this line and stick it in for X and Y, it'll make that equation true. Okay, any one of them. Now, that's all you need to have drawn. I'll mention it though. What if I pick that point and find its XY coordinate, plug it in for X and Y, it'll make that statement true. Okay, and I could go through the entire graph and say that. What did I just do? Okay, now I'm going to back up a little bit, but that's all you need to show me. It's the easiest way to graph this line. And I know you're all saying to yourself, but my teacher told me about y equals mx plus b. Well, that's nice. Why waste your time? It's a total waste of time. For this equation, it's a total waste of time, okay? It's just you can't do this any easier than this, okay? So if you're not sure how I got this 4 comma 0 and 0 comma negative 8/5, I'll go back and do it. But quite honestly, you should be able to do this in your head once I show you how I did it. Okay, so let's take a look at what I did. All I did for the x-intercept is I stuck 0 in for x. Sorry, I apologize. I stuck 0 in for y. Now, once I do that, what happens to that term that had the y? Well, negative 5 0 is just 0. It becomes meaningless. So you get 2x equals 8 and x equals 4. That's all you got to do. I mean, you should be able to do that in your head. If you can't, I'm kind of scared, okay? But you don't have to show me that. Just do it in your head and tell me, okay, the x-intercept is 4 comma 0, all right? For the y-intercept, you stick 0 in for x. And what happens to the term that had 0? It becomes 0, and it essentially just goes away. And you have negative 5y equals 8. Solve for y, and you get y equals negative 8/5. And then write it as a point. So we have 0 comma negative 8/5. Now, do you have to show me this work? Yes. Do you have to show me the stuff I just erased? No. But you have to tell me this is the x-intercept, this is the y-intercept, and then you graph it. Okay? That's your work. I don't need to see how you got the x-intercept. I don't need to see how you got the y-intercept. I kind of don't even want you to show me. You should be able to do it in your head. Okay, so right now, no more XY tables for lines. I won't take it. Okay? Just so you understand that. Now, I'm not saying there aren't other ways to graph lines. There are. But for this particular form, which I'll get to, this is something called standard form of a line. That's the easiest way to do it. Now, next time, I'll talk about, notice I didn't mention the word slope. Okay, most people don't really understand what slope is anyway. Next time, I will start talking about slope. But even after I've talked about slope, this is the easiest way to graph the equation of a line that looks like this. That's a basic introduction. You should know what a linear equation looks like, and if you can't do anything else, no more XY tables, but find the x and y intercepts. Of course, after you listen to the next video, that'll be the way you want to do some equations and not be the way you want to do other ones. But that's just a basic introduction to what a line is. And if you have any questions, please ask. Have a good day.